Okay, so what is your test on? This. Your test is on this. Okay. Finding the axis of symmetry, the vertex, and graphing the function when given vertex form or standard form. Number 4, converting from vertex to standard form. Number 5, getting a function from a graph. So you're given a graph and you need to get the function. Number 6, find the zeros of a function. Number 7, solving a quadratic equation by finding the zeros of the function. And number 8, solving a quadratic equation by using the zero product property. Okay, so who's absent? Who's absent? Is anybody absent? Miss Birkins is absent. Is that it? That's it, right? Nobody else? Andres was absent, but he is not any longer. I already checked homework, so you have to show me at the end of class. Okay. So what we're going to do is we're going to get started. Now, if you don't want to take notes, you don't have to take notes, but I recommend that you stay engaged. Part of being engaged is asking questions. I'm just going to blast through this material, and it's going to be up to you to stop me and say, hey, I don't understand that. Okay? Because if I don't hear that, then I'm just going to keep going. Okay, I'm going to ask, is that clear? Are there any questions? If it isn't clear or you have a question, just raise your hand. Okay? But I do recommend that you pay attention. 80% of the test will be exactly like this review. About 20% of it will be like word questions or maybe a different style of asking the same exact thing. Yes, sir?
Wait, will there be converting from standard form to vertex form?
No, that's not an easy thing to do. I mean, you can do it. It's much more challenging than going from vertex to standard. Okay, so let's get started. So the first thing is finding the axis of symmetry. Okay, and remember there are two forms. The first form is vertex form. And what is vertex form? Well, vertex form is f of x equals a times x minus h squared plus k. And where is the axis of symmetry? Well, the axis of symmetry is just x equals the x component of the vertex. Okay, remember the axis of symmetry, first off, what is the axis of symmetry? Well, the axis of symmetry is that vertical line which goes to the vertex of a parabola and splits it into two symmetric halves. Okay? And since it goes to the vertex and it's a vertical line, it's just x equals whatever the x component of the vertex is, and in vertex form, that's just h. So it's just x equals h when it's in vertex form. So what's an example of that? If I give you f of x equals 2 times x minus 3 squared plus 1, then the axis of symmetry is just that x equals, x equals what, class? 3. Because that's what h is. Okay? So that's the axis of symmetry. Standard form. What's standard form? F of x equals a x squared plus bx plus c. How do you find the axis of symmetry here? Well, it's just x equals negative what? B over 2a. So what's an example of that? F of x equals 2x squared plus or minus 8x plus 3. So in this case, a is equal to 2 and b is equal to negative 8. And the axis of symmetry is negative, b is negative 8 over 2 times 2. Negative times a negative is a positive. It's 8 over 4 equals 2. Okay. Like I said, guys, if you're like fiercely trying to take notes, that's okay. I don't mind it. But I'm gonna keep going. So it's gonna be tough to kind of keep up. I don't necessarily say don't, but just make sure you're not sacrificing your attention just to take notes, because this will be on YouTube. So you guys got that? So where's the axis of symmetry? The axis of symmetry is at x equals 2. Done. Does that make sense? Okay. Any questions on this? That's finding the axis of symmetry. Okay. Next. Okay. Vertex. How do you find the vertex? Well, in vertex form, it's very easy. In vertex form, we have a times x minus h squared plus k. Where's the vertex here? Where's the vertex? HK. Yep. That's why it's called vertex form, because the vertex is just right there. What's an example of that? F of x equals 2x minus 3 squared plus 1. And where's the vertex in this case? 3, 1. Okay. All right, so that's pretty simple. Standard form is a little bit more challenging. Once again, we have ax squared plus bx plus c. I'm not going to be giving you those forms on the test. You're going to have to remember them. If I were you, I would look over my notes, make sure I remember them. As soon as I give you the test and tell you to begin, you can just start. And usually I just give you the test, right? And you can just start as soon as I give it to you. I never say you have to wait or something, right? So literally as soon as I pass out the test, you can just write that right there on the test. Does that make sense? So, it's up to you, but that's what I used to do, and it worked for me. Okay, where's the vertex here? Well, the vertex here is negative b over 2a, and then I just plug that in, whatever the result of that is, into the function to get the value. So what's a good example of this? 2x squared minus 8x plus 2. First, I find negative b over 2a. So first off, a is equal to 2, b is equal to negative 8. So that's negative 8 over 2 times 2, which is positive 8 over 2. Positive 8 over 4 rather, which is 2. So I know my vertex for this one, the x component is 2. To find the y component, I just plug in that 2 in for x here and here. 2 times 2 squared minus 8 times 2 plus 2 is 2 times 4 minus 16 plus 2, which is 8 minus 16 plus 2. 8 minus 16 is negative 8 plus 2 is negative 6. And so I've gotten my vertex. Does that make sense, guys? Understand this? You see how we're building up here? See how we're building up? Okay, so we already got the x component with our axis of symmetry, right? And then all we had to do was just plug that in to get the y component, negative b over 2a. Okay, any questions on that? Okay. Next. So that's finding the axis of symmetry, and it's finding the vertex. Now we actually have to graph the function. So how do we graph? Amen. Look, graphing is the same way every time. How do I do it? Find the vertex, create the table, plug in your x values to get your y values, and then just graph it. Okay? What's the simplest way to think about it? Get your vertex, create the table. Because once you've got that table, you're going to know what to do. You understand what I'm saying? All you got to really remember to do is I have to get the vertex, and then I have to create my table. If you can remember that, then it's obvious what to do next, because you've done that for a long time. So, but the most challenging part, quite clearly, at least from my perspective, is actually recognizing that you have to find the vertex first. Once you recognize that you have to find the vertex, I think the rest is pretty simple. So let's start with one in vertex form. Let's say I give you f of x equals 2 times x minus 3 squared plus 1. Well, the first thing I have to do is find the vertex. Well, the vertex in this case is just 3, 1. Once I've found the vertex, I create my x f of x table. And where does the vertex go? In the middle. Then I go up, 1, 2, down, 1, 2. If I've done it right, I have a numerical list, or a list in numerical order. And then I just plug in my x values here. I get 2 times 2 minus 3 squared plus 1 equals 2 times negative 1 squared plus 1 equals, negative 1 squared is 1, so it's just 2 plus 1 equals 3. So that's 3. Then I plug in 1, 2 times 1 minus 3 squared plus 1 equals 2 times negative 2 squared plus 1 equals negative 2 squared is 4 times 2 is 8. 8 plus 1 equals 9. Then by symmetry, I have 3 and 9. Okay? Once I've got that, I go ahead and graph. Simple as that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Go ahead and graph my function. 1, 9, 2, 3, 3, 1, 4, 3, 5, 9. And there it is. Okay. Does that make sense, guys? Okay. So that's how to graph it in vertex form. Simple as that. Any questions on that? No? Okay. All right. So then let's go to standard form. I might give you f of x equals 2x squared. 2x squared minus 4x plus minus 1. What do I do here? I have to find the vertex first. Well, the vertex is at negative b over 2a, so a is 2, b is negative 4. So this is negative 4 over 2 times 2. Negative times negative is positive. 4 over 4 is 1. So my vertex is at 1, and then I have to plug that 1 in to get the other component. 2 times 1 squared minus 4 times 1 minus 1 equals 2 minus 4 minus 1 equals negative 3. So my vertex is at 1, negative 3. So I create my x, f of x table. 1, negative 3. I go down 1, 2, up 1, 2, and then plug in. Plug in 0. 2 times 0 squared minus 4 times 0 minus 1 equals 0 minus 0 minus 1 is negative 1. Plug in negative 1, I get 2 times negative 1 squared minus 4 times negative 1 minus 1. Negative 1 squared is just 1, so it's 2 minus a negative is positive, plus 4 minus 1 equals 5. And then by symmetry, negative 1, 5. Bam. Go ahead and graph it. And what do I end up with? I end up with these points here at negative 1, 5, 0, negative 1, 1, negative 3, 2, negative 1, and 3, 5. There's my parabola. Does that make sense to you guys? What did I do both times? Found the vertex, created the table, plugged it in, graphed the points. Done. Any questions on that? I know we're going fast, guys, but remember you have all the videos from all the lectures leading up to this, and then you'll have this video as well. Like if your way of studying is just literally watching all the YouTube videos, that's about 60%. The other 40% I would say would be like going through their homework and doing practice problems. Does that make sense? Okay. Next. Converting from vertex to standard form. So converting from vertex to standard form. This is arguably the easiest thing that you're going to do on this test. All you have to do is simplify. Okay? All you have to do is simplify. So for instance, I give you the example of f of x equals 2 times x minus 1 squared plus 3, let's say. Well, how do I convert this? That's clearly in vertex form. How do I convert it to standard form? Well, I simplify. Make this 2 times x minus 1 times x minus 1 plus 3. And then I FOIL 2 times x squared minus 1x minus another 1x, so it's minus 2x. Negative 1 times negative 1 is positive 1 plus 3. Then distribute that 2 in, 2x squared minus 4x plus 2 plus 3. Then combine like terms. I get 2x squared minus 4x plus 5. And that's my final answer. So we can see we started with vertex form here, and we converted to standard form there. So that's how we convert from vertex to standard form, is simply by simplifying. Simply by simplifying. Okay, any questions on that?
Well, you three gentlemen were on your computer. I hope you were redeeming your time. Of course.
Okay. Good. I hope it's not distracting anybody else. You're making your own bed at the moment. Okay. So, let's continue on. Getting a function from a graph. All right. So, let's say I give you this. I give you a graph that looks like this. And you see these 2 points. And this is literally all you're given. And I ask you to get the function that gives this graph. Your quiz was basically on this, okay, in a lot of ways. Like I said in the beginning of the day, your quiz is graded. I'm just not handing them back until everyone's taken it. Just waiting on 2 people. With that said, though, if you want to see your quiz, to see how you did or what you got wrong, you can come and see me. You can come see me, and I'll be glad to give that to you or show it to you. Okay. So, getting a function from a graph. Well, what you're going to do is you're going to put it in vertex form. Okay. So, let's be smart about it. Excuse me, sorry. So, here's my graph. And what we're going to do to get the graph from the function is we start with vertex form. A times x minus h squared plus k. Now, what's the first thing that I do? Who can tell me? Plug in the vertex. Okay, I know that this is my vertex. So my vertex is at 4 and -2, and that's what I plug in for h and k, right? So I plug that in, I get f of x equals a times x minus 4 squared plus -2, or just minus 2. Good. So literally in a question like this, if it's free response, you're going to get points just for writing down vertex form. So remember to write down vertex form. Okay? And then you're basically halfway done with the question. Now I have to solve for a. Okay? How do I solve for a? What do I use? This point here. So this is x, f of x, 5, 0. I plug those in. 0 equals a times 5 minus 4 squared minus 2. 0 equals a. 5 minus 4 is 1. Squared is 1. So it's just a minus 2. Add 2 to both sides. And I've solved for a. A equals 2. Now that I've solved for a, what do I do with that? Plug it back into the function right here, and then I'll be done. F of x equals 2 times x minus 4 squared minus 2. That's your final answer. Okay. Does that make sense, guys? All right. So this is arguably one of the more challenging aspects, but the reality is that you guys got a quiz with like 6 of these types of questions on it. Okay, so you've already kind of been assessed on this. The reason why it's challenging is because you have to do some algebra and you also have to have some mental leaps. The first mental leap is to realize you just plug in your vertex. The first thing to do is you have to start with your vertex form. If you don't write vertex form down in your paper, then you are just handicapping yourself. I don't even know. I would have to juggle way too many things in my head to do this problem without first writing down vertex form. So you write down vertex form, then all you have to do is plug in h and k, and then you're halfway there. Then that's the first mental leap is to write down vertex form. Second mental leap is to plug in the vertex. Third mental leap is to plug in that final point and solve for a. Once you solve for a, you just plug it back in. So it's a couple things that you have to remember to do in terms of the process, but it's just like making pancakes, you know? Mix up the batter, put it in the frying pan, put on some syrup, you know, some butter.
0.50, the 5 would be the x, and the 0 would be the a.
Would be the f of x.
F of x.
Because a point, very good, a point is in this form, x, f of x, right? So if my point is 0, 5, then x is 0 and f of x is 5. Does that make sense? You don't have the a value. You have to solve for a. Any other questions on this? Okay. Moving forward. Finding the zeros of a function. All right. So finding the zeros of a function. Finding the zeros of a function. Let's say I give you a function, f of x equals 2 times x minus 1 squared minus minus 8. Okay. I give you this function, I say find the zeros. Okay, you're not going to have a graphing utility. If I were to give you a graphing utility like Desmos or a graphing calculator, you could just graph it and find where the zeros are. And in fact, that would be the first type of question that I could ask you. So in this case, let's say this is a completely different one. But if I asked you where the zeros are, I wouldn't necessarily give you these points, but you'd see it just like this, and I'd say, where are the zeros of this graph? Right? And you'd have to know that the zeros are the what intercepts? The x-intercepts, not the y-intercepts, the x-intercepts. And then you could say the zeros are at 3 and 5. So really the first part of this is remembering that the zeros are the x-intercepts. That's the first part of it. And that's the easier question, obviously, because you're just looking at a graph and saying, oh, the zeros are there and there. Okay? Now, excuse me. Now, if I ask you to find the zeros of a function like this, you have to create a table, okay? And you have to trust the fact that I'm asking you to find one that creating a table, the way that I tell you to do it, will provide you with the zeros. If you remember in your homework, there were a couple ones that when you created the table, you didn't get the zeros, right? You guys remember that? And then you had to graph it. Well, I can't do that because I'm not giving you the utility to graph it with. So you have to trust the fact that I'm giving you one that you'll be able to find the zeros by getting a table. And so that's exactly what we'll do. And here, when we find a table, we start with the vertex, which is at 1, -8. Then we create our table, x, f of x, and we put our vertex right there in the middle. Smack dab in the middle. Go down 1, 2, up 1, 2, and then plug in. You get 2 times 0 minus 1 squared minus 8 equals 2 times -1 squared is 2 minus 8 is -6. Plug in -1, we get 2 times -1 minus 1 squared minus 8 equals 2 times -2 squared minus 8 equals 2 times 4 minus 8 equals 8 minus 8 equals 0. Well, there's my 0. And then by symmetry, I have them here. Do I have to graph it? No. I can see immediately that the zeros of my function are at x equals -1, there, and x equals 3, there. And remember, it's not where x is equal to 0. That's the y-intercept. It's where the function is equal to 0. Okay, does that make sense to you guys? Yes, sir.
No, I figured it out.
Okay. All right, so how do you find the zeros? You do exactly what we've done. You see how like the skill, find the vertex, create the table, okay, and then just look at the table and see where there are zeros. If I ask you to find the zeros and you don't wind up with zeros, you should probably just check your work, right? Any questions on that? No? Okay. So that's how you find the zeros of a function. And remember, the zeros of the function are where a function is equal to 0. If I were to plug that in, 2 times x minus 1 squared minus 8, there you go. There's my zeros at -1 and +3. See? -1 and +3. Okay? So there are my zeros. Any questions on that? All right. Let's keep going. Solving a quadratic equation by finding the zeros of a function. Now this is almost exactly the same, except instead of just giving you a function and asking you to find the zeros, I would say to you, for instance, I've got this equation, 2 times x plus 3 squared minus 2 equals 0. I would tell you that, okay? And I would say find the solutions of this equation, okay? And how could you find the solutions of this equation? By finding the zeros of the related function. Remember this? The zeros of a function are where the function is equal to 0. Well, that's a function equal to 0. So you find the zeros of that related function. How do you find the zeros of the related function? The exact same way. You find the vertex. In this case, it's -3, -2. Then you create your table. X, f of x. Put your vertex smack dab in the middle. Go down 1, 2, up 1, 2, and then plug in. 2 times -4 plus 3 squared minus 2. -4 plus 3 is -1, squared is 1, times 2 is 2. 2 minus 2 is 0. Plug in -5. 2 times -5 plus 3 squared minus 2. -5 plus 3 is -2. Squared is 4. Times 2 is 8. Minus 2 is 6. Okay, cool. I actually didn't even have to get this point, because once I have that 0, I know by symmetry there's another 0 right there. So I found my zeros here and here. So what does that mean? Well, what that means is the solutions of my equation are at the zeros, at -4 and x equals -2. And to check your work, you can always just plug them back in and see that it ends up equaling 0. Does that make sense?
So your points are whatever equals 0.
Yeah.
At the second part. Okay.
Wherever the function is equal to 0, that's the zeros of your function.
Gotcha.
And the zeros of the function are where the function is equal to 0. So that's a function equal to 0. You find the zeros of that function. You find the solutions of that equation.
Gotcha.
Okay. Very good. Okay. Last but not least, solving a quadratic equation by using the zero product property. Hang in with me here. Okay. So this is the homework that you guys just did, right? So I'm not going to spend too much time. I'm just going to blast through it. X plus 3 times x minus 4 equals 0. If this times this equals 0, I know, let's make this 2x plus 3. 2x plus 3, I set that equal to 0. And this x minus 4, set that equal to 0 and solve for x. Okay. Subtract 3 from both sides. 2x equals -3. Divide both sides by 2. X equals -3 over 2. Here I add 4 to both sides. I get x equals +4, and I'm done. Those are the zeros of my equation. Okay? Does that make sense? Any questions on that? Okay. Let's continue. There are 2 more things. The next thing is if I have something like this, 3x times x minus 4 plus 2 times x minus 4 equals 0. Okay, in this case, remember I have to use that distributive property because I have the like terms. So I pull that out, and then I group these 2 terms, 3x plus 2. So I get 3x plus 2 times x minus 4 equals 0, right? Once I have that, I know the product equals 0, so each one individually, either that or that one has to equal 0. X minus 4 equals 0. Then I just go ahead and solve. We remember Mr. Bolton doing such a fabulous job at teaching us this. That was a lot of fun, I think.
Thank you.
Good job. We get x equals negative 2/3. And then here I add 4 to both sides. And I get x equals positive 4. Any questions on that? All right. And then the last thing, just bear with me for just a moment. If I have x times x plus 3 minus 4, or plus 4x plus 12 equals 0. Okay, This doesn't look the same, right? I need an x plus 3. What do I do? What do I do? Who can tell me? Bring out that 4. And this becomes x plus 3 equals 0. Then I distribute out the x plus 3. I get x plus 4 times x plus 3 equals 0. Set them individually equal to 0. X plus 4 equals 0. X plus 3 equals 0. Subtract 4 from both sides. Subtract 3 from both sides. Bam, bam. X equals negative 4. X equals negative 3. And I'm done. Any questions? All right, so like I said, about 80% of your test is going to be on this. There are some aspects of these functions, okay, that I didn't necessarily delineate for you. I didn't just tell you about them, okay? It's going to be your responsibility to study. It's going to be your responsibility to understand what these quadratic functions are, what these aspects are. Look through your book. Go ahead and study. This review is not fully comprehensive, but it is a very good framework to help you to study. Okay, so go back and watch those videos, look through your homework, make sure you understand every single problem, and you will ace this test. All right, any questions? Okay, God bless you guys. Thank you for your attention today. Amen.